Thanks everyone for joining us, and also thanks very much for your understanding on my mistake early this Monday. Hopefully you all had a better Monday than I do. I actually realized that I forgot to ask for everyone's email addresses. So I think today's webinar runs sponsorship from LinkedIn Premium. I was able to contact a lot of you and get you guys the details you needed to be here today. So thanks very much for joining us. We've also got James Abella here with us as well from Garden International School in Malaysia. You want to introduce yourself, James?
I am James Abella. I'm the head of computing at Apple Distinguished School in Malaysia, Garden International. Great to see so many people from Malaysia, Singapore, and around the region. And I'm looking forward to enjoying today's session. Oh,
Thanks.
wow. And Australia now too.
Yeah, we've got a few actually. There's a few from South Africa and all over the place at the moment. So we've got a
Wow.
couple of people rolling into the room, but James is going to help me run the webinar as we're going through, and also focus on the chat. But the layout for today's format, basically, I'm going to run through this AID framework, which I've developed as I've started to introduce artificial intelligence or mainly general artificial intelligence to our faculty and also our students. So we're going to look at some fundamental knowledge on AI. We think it's quite important for our students and also for our faculty to understand a little bit about how AI actually functions, or this generative AI. We're going to look at the fun stuff, which is what you're here for, the integration part. How can we utilize generative AI to actually build some applications using Swift and Swift Playgrounds? We're going to define AI usage and expectations. So, of course, we're in the classroom setting, so we need to speak to our students and also our faculty about how we expect people to use this technology. And then I'm going to finish on a little bit on how we can further some of our projects and how we can develop them a little bit more. So I will actually be recording this. I'll try and share it out with you. I do need permission from people before I share it out. So provided that all goes ahead, I will hopefully share a recording. But please do stick around. We'd love to have your participation, also some of your thoughts as we go along and your questions, which you won't get from a recording. So with that, your cameras are turned off and your microphones, but if you would like to share something, please let us know. We can always unmute you. It's just also because we do have some students in the room, so we want to make sure that we do protect their privacy as well. As I mentioned, please do write any questions into the chat. As you've been introducing yourselves in the chat, you can also ask any questions. And I've got James here who's going to yell out those questions as we come along, so that we can make sure we surface your questions and that we allow you to have your voice heard as well. We want to try and make this as interactive as possible. And last but not least, we do have some emojis available within Zoom. So if you hear something you like or you want to hear more of what I'm talking about, please make sure that you use a fire emoji. If you want to hear a little bit less, we've got some other emojis which are a little bit less tasteful. And then, of course, if you want me to slow down, the preferred method is for a turtle. And I'll try and look out for those as we're going along, so that I can control the pace a little bit. So this is a two-part series. So you're going to hear a lot from me and James today as we explore this generative AI technology. It's a pretty exciting day for generative AI today with some new releases from OpenAI. So we'll reflect on that a little bit. And then on Thursday, because we have a public holiday here in Hong Kong tomorrow, on Thursday, you're going to hear a little bit more from our students about some coding initiatives and some projects which they're passionate about. So how you can start to engage with your students in discussions around AI, but also coding in general, things that they're interested in around leadership. So I'd encourage you all to—
Daniel, because there's students on Thursday, will we not be recording that session?
I'll do my best. Again, I just need to get permission from the people who I show in the presentations to make sure that I can share that widely. However, I will try to share those recordings. But so you don't miss out, I'd encourage you to attend. That'd be the best option. So there is an option here for you to work along with me and ask questions and troubleshoot as you're working through these projects. So everything I'm going to show you is available on both Mac OS and also iPad OS. I'll try to make it device neutral. I know, for example, at James's school, he has both devices. As we do here, we are one-to-one Mac program, but students do like to bring in their iPads as well. We have some trolleys around. So this will work on each of those different devices. And as we go through and I share the different resources, as James has just put in the chat, I'll also store everything within a Padlet. So if there's any slides you like, diagrams, I've tried to include high resolution images of each of the slides that I think are more important. But I'll also keep this available for you. So if you want to refer to it after the summer holidays, if you're working within the system like we are, and you are on the edge of finishing the school year, all these resources will stay available for you. So you can work through those as we go. So without further ado, we're going to start to get into the materials. And I just want to give you a little bit of an oversight into generative AI. So I know some of you have started to explore with AI, but some of you may still not quite understand how all this magic kind of works. So I'm going to do a very quick demo. It's a way that I sort of explain it to faculty and staff. But the target for this webinar is basically for us to build a SwiftUI task app. So as it looks here, but there are some things we need to consider. We need to consider the understanding of the basics of SwiftUI and the sort of constructs that go along with that. There are some coding basics, more semantics than syntax, because we do have generative AI to help us with where the dots go and where the commas go and all those kind of things which tend to frustrate us when we're first starting to learn to code. But we also need to consider, when is it appropriate to use generative AI in terms of our pedagogy or our classroom? And then how do we use generative AI? So this is kind of a new technology. It seems like I've been talking about it a lot within my role as the school-wide technology coordinator. But essentially what we're looking at with this technology is it's simply just mathematics, which is a kind of simplified version of what these fantastic things do. These large language models are in fact, or neural networks are actually in fact modeled off the human brain, which kind of makes you think that the way we actually approach questioning these chatbots, the way that we look for outputs is quite similar and feels quite familiar for us. Essentially, what it's doing is predicting what the next word or the next character will be. A bit similar to if you were having a conversation with you, or in fact, James is listening to me now, and he's thinking, what's the next word that I'm going to say? When's he going to pause so that I can interject or put my 2 cents in? And that's essentially what we're doing. And we saw today, OpenAI actually released a new functionality for ChatGPT 4, which allows you to communicate with voice to the chatbot, which is going to change a lot of things and a lot of what I'm going to share with you today. But what's fascinating about this new functionality is what you can do is actually interject when it's talking. So if you're speaking to these chatbots, or you put in your prompts, they often start to generate down and start to produce what you wanted. But if you can start to see that it's not quite what you want, you often pause it, you have to reprompt. So it's going to improve a little bit of that and make it a bit more conversational between when we respond to these different chatbots. Another thing we have to be conscious of as we're working with these chatbots is we can lead them garden path. And I'll show you what I mean by that in a little bit. And it's what's referred to as chain of thought prompting. Often we have a place where we want it to go. And I'm going to show you how it's not advisable for students or even faculty to try and look at these technologies as something that you could put in a single prompt and produce this beautiful app that you think will be suitable to submit. Apps are a little bit more complicated than your English essay or a simple maths problem. We need to think about lots of other things, which we'll explore. So if you know anything about Australians really like to teach New Zealanders and vice versa. So we've got a little example here with this crossword. So if I was to work through this crossword, thinking about my chain of thought prompting, my one across, my prompt would be a colloquial term used for a shopping cart. This may be different in different countries, but we often call them trolleys in Australia. My second prompt for two across would be the term referred to for Indigenous Polynesian people of New Zealand, known for their cultural language and traditions. And they, of course, are the Maori people. Three down. It's an epic fantasy film directed by Peter Jackson, famously filmed across New Zealand's picturesque landscape. James, do you know this one?
Oh, might be Lord of the Rings.
It is, in fact, Lord of the Rings. And this is where we start to run into a problem. So my next prompt is a natural phenomenon, the common in New Zealand, due to its location on the Pacific Ring of Fire, which causes tremors and shaking. So, of course, this is... Oh, sorry, I missed one. Our iconic flightless bird. Thank you for that. I just saw it pop up in my chat. It is, in fact, the kiwi bird. I was jumping ahead a little bit there. So for my 5 down, of course, we're looking for earthquakes here. But of course, that's not going to fit because New Zealanders, like the kiwi bird, are strange characters. And they called shopping trolleys trundlers. So whilst we may have this train of thought prompting where we think that we're going to go to a place where we're going to reach our goal, often there is context that we don't understand. Often there is additional information that needs to work through the process to ensure that we do create the product that we are intending. And this is particularly important when we are building applications and why we still need to go through that iterative process to ensure that what we create is what we intended. When I'm introducing prompting, and again, this is changing every day as we work through, one of the frameworks I like to use, mainly because it's easy to remember, is the PrEP framework, which was produced by Dan Fritz Tweets on Twitter, or now X. And the reason I like this is it's just structured. It allows faculty and students to think a little bit more about when they're prompting. And it's not that we need to spend a lot of time developing our prompts to a point where we think that we're going to put in this fantastic prompt is going to give me everything I want. As I said before, we want to get into this iterative process, not only with building of our application, but also with communicating with a chatbot to get to where we want to. So there may be follow-up questions. You may not be happy with the output as it runs, but we need to be explicit with what we're creating and the parameters around the prompt to ensure that what we create is along the right lines. And we continue to move down that path with our chain of thought prompting to ensure that what we create is as intended. So this all sounds pretty perfect, but of course there are a couple of other things within generative AI that we also need to consider. First of all, hallucinations are still a thing, sometimes, particularly with mathematics logic, which is important for coding. We may not get the result we want, or it may be very confident in saying that what we produced is correct, but in fact, it may not. Of course, there is some inherent bias, as we know. It's very important for us to talk about as computer science teachers, but also technologists, about the bias within data sets and how that may affect our output. We also need to consider our students' data privacy. So when we're suggesting tools for our students to use, we need to think about what we allow them to use, what is acceptable legally, but also protecting our students. So for this project, I'm actually going to use Poe, and this isn't the product which we actually recommend within our school. We use Bing Chat purely because we have an enterprise agreement with them. We know that our student data is safe. I'm using Poe today because it's available internationally, even in China. It allows you to play with different models. There is a Mac OS, iOS, and web version. So it's just very accessible. It also has a trained SwiftUI bot as well, which helps you with building applications. So that last point is equity of access, making sure that if you suggest a tool, it's not something that's going to require a VPN. It's not going to require a US phone number so that you can access it, to make sure that your students do actually have access to it and your faculty as well. So today we're going to be using Poe, but by all means, there's advantages and disadvantages of the different bots. James, you were actually saying that you were having some good success with Gemini recently.
Yeah, it's not bad. I think the paid for ChatGPT is the best of the ones that I've seen. And I think Claude keeps on improving and improving. So be quite interesting. But with Swift, I use the paid for ChatGPT, and that's very successful. but ChatGPT 3 is way below Claude.
Yes, definitely, definitely. So as I mentioned, like some of these fundamentals, some of these pedagogies which teachers have used previously, like our design process, are still equally important when we start to use generative AI. As we mentioned, we want to make sure that we can iterate through our design, and that includes breaking down our problems, working through testing, and then re-evaluating and brainstorming again. And we'll work through this process, as I mentioned, as we actually build out our application. The other model, which is very popular with computer science teachers, is the PRIM model. And I've been utilizing this with students as well to look at not only using generative AI to ensure that we think about what we might want the output to be, but also to develop their applications further. Sometimes we'll do timed exercises where we'll first of all create a draft without using any generative AI to figure out exactly what we want to do, and then we'll put it into the chatbots and start to develop ideas further. So the PRIM model, which is widely used, I think also, James, in your Cambridge curriculum, but it's a fantastic framework which we can utilize and continue to utilize within our generative AI work as well. So let's get into some of the fun. We're going to start to look at building these applications. So hopefully you have Swift Playgrounds installed. If you haven't used Swift Playgrounds before, I'm going to give you a quick sort of overview of the application. It's fairly simple, and this is why I like to use it. I find that whilst we can build applications within Xcode, you're almost teaching a new piece of software as you would if you were teaching, I don't know, video editing or something like that. You need to teach the actual interface. Whereas Swift Playgrounds is a lot smaller, both in footprint, in resources. It runs on older machines. And as I mentioned, it's a consistent experience between Mac OS and iPad OS. So while some of these schools have BYOD, bring your own devices, it's important to make sure that sometimes we have that equity in our software as well as equity in our AI tools. So once it first loads up, you're going to have your project directory, all the different things that you've created, and you can see all the different things that I've played with there. But on the bottom right, there's this option for See All. And within that See All, it'll bring you to a screen which has lots of resources which allow you to explore the language of Swift. So if you're very new to the Swift language, I'd recommend that you do have a little play within this space. James and I mentioned before you guys all came in, we're talking a little bit about our practices within the classroom. And we still get our students to do a little bit of fundamentals of coding before we let them loose within generative AI. It just ensures that the questions they're asking, they have the language and the syntax or the semantics of how to ask correct questions. And even if it's not correct, even if it's not saying, I want to use a for loop or I need to use an if statement here, the way they structure their questions is a little bit more direct, which allows them to get better results. So we still have one or two projects which we start. So going back to our project directory, ticking on that box, sorry, on the top left there, going to My Playgrounds, it brings us to our project directory. To create a new application, we're going to click on New App Project, which is on the bottom left. From there, it'll boot up and create a new project ready for you to go. Now, this piece of software, this little app package, can actually be transferred between Mac and iPad. So if you're in a school where the teachers have Xcode or teachers have MacBooks, but the students have iPads, you can still mark their work, you can still collect their work, you can still run them. You can also very easily publish the applications, and James has a great video for that, which I'll share in the Padlet because I forgot to add it in. But James has a great video where it actually builds projects from the Mac and allows you to share them within students. So it's a pretty cool way to showcase students' work. But as it builds up, this is probably the most complicated part that you're going to see. This is the main struct where all of your code needs to sit between. And I do have some videos which James will share in the chat, which help explain stacks and these structs. But it's a little bit complicated for students when they're first building. Within our courses, we actually don't follow the CSTA standards or the ISTE standards. We actually build all of our courses towards the US arts curriculum or media arts curriculum. So we're more interested in the students communicating and producing products. We're more interested in the process of what they're building rather than teaching them this is a for loop, this is an if loop. So our language and what we're looking for is slightly different from someone perhaps who's doing an IB exam or doing an AP exam where it's more about the algorithmic thinking and designing algorithms. But from here, we have our basic struct, and all of our code will actually sit between our line 5 and our line 26. This is the main body. And this is very similar to if you've ever done any web development, you know that within your HTML tags, all of your code will sit between either the head or the body tag. So learning a little bit about that structure. But this is essentially where, when we're prompting our generative AI, we're going to ensure that we put our code within those brackets. And this is where a little bit of frustration will come in. But of course, we can use our AI to help troubleshoot as well. So a little bit of understanding of SwiftUI. SwiftUI is essentially that structured language. It's that HTML. It allows us to actually build our interface in a very simple way. And there's 3 main components. There's a vertical stack, a V stack, and horizontal stack, an H stack, and a Z stack or a Z stack, which allows you to stack things on top of each other. So if you want to layer different things. So you can see here I have my little icon and my word sit next to each other within an H stack. I have those laid in a vertical stack, and I could have multiple H stacks underneath that. And then I have a Z stack, which allows me to create that nice shape that sits behind those different labels. So those are the main kind of building blocks of what we're going to do. And it's helpful for you to understand, but of course, we're not looking for you to actually type. We're going to be using generative AI shortly. There's also a reference document from Apple's documentation, which can help you out with this a little bit. But essentially, our V stacks allow us to vertically stack our different views. H stack allows us to horizontally stack our views, and Z stack allows us to put everything on top of each other.
Daniel, I just want to interrupt at this point because I think we've had this discussion before. We strongly advise when it comes to students, they've got to master their V stacks and H stacks before you think about the Z stacks.
Yeah.
I think that's really important because Z stacks are a leap to another dimension.
Yeah, yeah. Definitely. So then we're going to bring up my Poe application. So I'm going to just do a little bit of multitasking here. I found my application and open it up. Okay, so you can see there I have my SwiftUI bot, and I'm just going to drag that so it sits next to my application. So the screenshots you're going to see from now on, it's actually going to have this sitting alongside it. But of course, I'll show what shows underneath that for you. So I have my blank template. I have my chatbot up and running. And of course, you can use ChatGPT. You can use Google Gemini. Actually, I don't think they have a Mac OS app for that one yet, but you can use ChatGPT. You can use Poe. Poe allows you to access Gemini, Anthropic's model, and all those different models as well, which is quite cool. So the first thing we're going to do is to prompt our chatbot to say, I want to actually develop this app a little bit. So I've created my blank application. I've simplified it a little bit here for you. I've removed some of those Z stacks and things that I was demoing, and I have my hello world that sits there. Okay, so I'm working within those brackets from line 5 to line 10. The first thing I want to do is I want to allow the user to input something. So I want to have some sort of text box And I want to ensure that we store that information there. So in order to do this, we need to use a state. And this is where it comes into a little bit of understanding of what we need to create. And of course, you could do this in simplified language, but a little bit of context of how users interact with devices, that systems thinking piece. But what my prompt would be is, in my SwiftUI app, I'd like to create a state called my text, which will be displayed in a text view, and it'll also be bound to a text field. This produces my code for me, which allows me to then copy and paste it into that space. Again, I do have a video for you to help explain states in a little bit more detail. Of course, we're just running through the basics for today because we have such a short amount of time. So now here I have my state. My state is declared above my body, and then I can utilize that within the text field. So I've referenced that there, and it allows me to then input some text. And you can see here on my right-hand side that it actually displays my text. So next, what I want to do is I want to create a list. So I can create, again, another state, and that state just allows me to reference this different property. And then I'm going to display the first item within my list, which is clean my room. So I look for that first item. And of course, there are different ways to do this, which I'll show you in a minute. We could just do like you would in Python or another language, refer to that first item within the list. But I'd say in my prompt, please now add another state called my list, which will be a list of strings. So for example, clean my room, pay my bills, and these will be my tasks. I want my text view that is already created, and I want to show the first item within the list. This has produced all of my code for me. But you can see how I'm iteratively working through my application. I'm continually testing, retesting, and building up my application step by step. So now I have my item, it displayed my first item. But what if I want to display different items? So here you can see there's a different way of how to display the first item within a list. And I have both items on my list displaying. So then we'd want to introduce some sort of loop. Now, this is slightly different syntax from what people may be used to, because perhaps you'd use a for loop. Within SwiftUI, we actually have these for each, which allows us to basically create a for every item within a list. So now I have those different items. I don't need to individually type them out. It's a little bit more dynamic. So if I had more items with my list, it would show multiple items. Okay, fairly simple so far. So next, I'm going to create a button. So now I want to be able to add items dynamically to my list. So I had my text input. I now want to create a button, which allow me to add all of the user inputs to that list. So you can see there on the right-hand side, I've typed a new item. When I click the button, it then allows me to add that. So you notice we're still developing these views within that vertical stack. I've now stacked my different text views, my text field, and then underneath that, I have a button which allows me to add those different items. So it's not quite working yet because we need to embed this into a list to make it a little bit more presentable. And that will allow me then to add some additional functionality. So this is really the beauty of SwiftUI. We have these built-in gestures. We have these built-in functionality that we can easily access to make things work really well. And the functionality I'm going to add here is to allow it to remove items when I swipe. This will allow me to remove items from that list, and then I can add them in. Okay, so you can see how a lot of that formatting kind of jumps for you. And what I've really created here is something that's quite functional. I've created a very simple app in about 5 steps, which we could do with students very quickly. And traditionally, if we were going to do this as a task, if I was going to teach my students to learn the struct, learn the syntax on how to build up an application, learn how to stack those views, learn how to use horizontal stacks, V stacks, and Z stacks, this would be a pretty solid C++. But as I mentioned before, I'm not really interested in what they can produce in terms of the code. I'm interested in the product. What can we do from here? How can we build up this project to take it a little bit further? Because I think that's really what generative AI is going to do. It's going to allow us to extend our projects, expect a little bit more from our students, and really start to develop these a little bit further. So we're going to leave this for a little bit now. I want to speak to you a little bit more about the expectations for our students, and then we're going to come back at the end to talk a little bit more about that integration piece. So I suppose what you're thinking right now is, well, do we really need to teach any code? And James, what was the thing you reminded me of this morning about the
Yeah, well,
calculator?
we've had calculators for like 30 years, but maths teachers still need to teach what a calculator can do, because without that basic understanding, you're just going to be putting random numbers into a calculator.
Yeah, exactly. And I think it's a similar sort of thing. We need to still understand what is actually happening. And there's a good little video here. It's very short from Bloomberg, a little interview with Sam Altman, which I think kind of summarizes that a little bit. And I'll just play that for you now.
What do you think kids should be studying these days?
Resilience, adaptability, a high rate of learning, creativity, certainly familiarity with the tools.
So should kids still be learning how to code? Because I've heard people say, don't need to learn how to code anymore. Just math, just biology.
Well, I'm biased because I like coding, but I think you should learn to code. I don't write code very much anymore, although I randomly did yesterday. But learning to code was great as a way to learn how to think. And I think coding will still be important in the future. It's just going to change a little bit or a lot. We have a new tool.
So I think that's essentially it. We know as teachers that what we're trying to do is get our students to think. And with the onset of generative AI, we know that students are going to have to rapidly learn new skills, learn new ways of thinking. But we know that we still need to teach computational thinking. We know that coding improves the persistence, enhances the creativity, and teaches critical thinking. But essentially what we want to do is to solve problems, solve real world problems, to actually build things that matter to students, that matter to ourselves, and matter to our communities as well. And they can be big or they can be small. So through the last year, there's been some pretty pivotal conferences. There's been lots of government discussions. One of the fundamental conferences which I followed was the UN conference on education and industry and the effects on AI. And that was followed up by the Beijing Consensus on AI and Education. That was informed by the UN. And out of that came 5 different things which would be valuable within education in the future. And that's AI literacy, critical thinking, problem solving, creativity, and collaboration. I think we can all agree that within our classrooms, this is where we think that coding fits well, but also where we think that we could implement generative AI. And within our school, something that which we've borrowed from ISB Bangkok, International School of Bangkok, is this traffic light system. So I don't know if we've got anyone from ISB in the room. I think we might have 1 or 2. But this traffic light system is fantastic for telling students exactly when we would like to utilize and when we would not, because sometimes we may want them to think for themselves. We still need to stretch that squishy brain muscle every now and then and get them to think for themselves. So what we've tried to implement within our assessments is to say, when do we want students to utilize it? And being clear, because we don't want the usage to be swept under the rug. We don't want students to not talk about their practice or talk about what works and what doesn't. So it's a very sort of simple tool of how we can use this. So for example, if my AI gave me an answer or a block of code or wrote the algorithm for me, then this wouldn't be acceptable. If the task was for the student to write the code and they've used AI to do it, then that wouldn't be acceptable. But of course, we could modify this slightly. Perhaps the AI tool generated a structure for an outline for my project. Perhaps it gave me that starting point like I've just shown you with my task app. Perhaps it provided deeper questions, allowing me to reflect on my idea. This would be okay, but it depends on, again, Did the teacher actually want you to generate this? Did the teacher actually want you to think about some deeper questions? What skills are we actually trying to get the students to develop? But of course, what it is fantastic at is to help our students with technical documentation, implementing some functionality which may be a little bit above what they would like to achieve, or also just understand some concept or explain things in a different way, and using it as that co-pilot in their education to actually build up their understanding. What I really love it for is to extend our apps within different functionality. When students start to move beyond the basics of simple touch gestures, using the camera, microphone, and keyboards, when they want to start to create, two apps that may communicate to each other through Bluetooth, and there's some more complicated libraries which go along with that. Or if they want to start playing with some of those movement sensors and graphing that data, perhaps the mathematics is a bit above a 7th grade level, and they need a little bit of support with that to really get the functionality in place so they can solve the problem that they're trying to, using their digital literacy skills, I suppose, to research and develop the functionality of their application. And I think that's really that sweet spot of where we can start to use AI. So moving back to our application, how are we going to move this C+ app a little bit further? So we all have our different thinking strategies, and normally a computer science curriculum or a technology curriculum will have sort of two sides, the yin and yang. We'll have our thinking methodologies like design thinking, computational thinking, systems thinking, but we also have our general ICT capabilities, which would be the ability to create, to communicate, and to investigate. So design thinking, as hopefully a lot of you are aware of, this isn't new. This is Stanford's design thinking. It's a non-linear design process. And what's the really powerful thing about design thinking is that empathizing piece. Sometimes I won't go through the whole design thinking process. Sometimes I'll spend time just working within that empathizing, understanding what a problem is and how we want to solve it. What are the parameters around that? Back when I used to teach computer science in Australia, we spent a lot of time drawing DFDs and ERDs and really thinking about the user and the system. Thank God those days are gone. But it's still quite important for us to do that kind of needs analysis and think about the development.
And I could have done with that today, to be honest.
Yeah, databases. I didn't mind the actual flow chart part of it. It was how structured and the rules that went along with it for a month. Exam.
I mean, it's horses for courses, right? And I think with AI, we're going to be even more important to do that testing part of things.
Yes, yeah, definitely. But we're still teaching that computational thinking, right? We still want to.
Yeah, absolutely. We still want to solve problems.
Yeah, we still want to break down our problems. We still want to design algorithms. We still need to abstract those problems to ensure that what it is we're actually trying to create or what we're trying to solve to build up that problem. You're not going to build a multiplayer game in a single shot prompt. We need to break down the problem, figure out what it is, and then design it appropriately. And the piece that I love about computer science is that systems thinking bit. How does the user interact with it? How can we improve our user interface to increase engagement? How do we look at the user analytics and look at how we can improve that interface? So we can go a lot further with our applications. And it's something I struggled with when I was developing my courses. I said, yeah, we're using the design thinking process, or yeah, we're using the design cycle. But we'd never really actually iterate. We'd go through the process, they'd come up with a problem, they'd submit it, and I'd mark it. But we'd never actually have the time within our course to actually say, okay, this is fantastic, or look, we've got 3 different versions of this task app. How are we going to change that? How are we going to modify it to actually make it an improvement? So as I was saying, what I hope generative AI is going to do, and what it started to do within our classrooms, is to allow our students to go a lot further with their projects. We can create the basic functionality very quickly, and we can start to focus on that systems thinking, that point of view of perhaps the input, the way we're doing it, isn't the best or most effective way to work. Now, often when we're building apps, and I'm going to reference the United Nations Sustainability Development Goals in a second, but we try and think of these huge problems, but problems that are personalized to you are the most important one. And that could be, you know, the lunch line, or it could be a little application that helps your little brother or sister to read. You know, it's something which means something to you, and that's hard for AI to replicate. When a student puts themselves into a project, that's when projects become really powerful. And we don't want to take that human aspect out of the products that we develop. We don't want to say, here's my problem, robot, you solve it for me. We want to ensure that people are at the heart of everything that we produce. And the UN Sustainability Goals are a fantastic place to start, but they are very grand. They are problems which the UN is trying to tackle, and often for a 13-year-old, that's very difficult to understand of how they could make an impact. So sometimes we do start small, sometimes we do look at big things, but this is definitely a way to start to inspire.
I mean, we are trying to affect number 3 and 4 by making maps of our school and putting them into an app. And there's a lovely little Swift project coming along. And yeah, 3 and 4 sound grandiose, but just helping the kids get used to secondary is what it's about. So having plenty of those little examples from those grandiose ideas really helps.
Definitely. The other model I like to use, and I'm going to step through this one with you, is the Scamper method. So essentially what this is it's just another acronym. I know I've thrown a couple of them at you. But basically what we like to do is to put some prompts together to encourage students to reflect on their applications. So substitution, combining functionality, adapting, modifying, looking at the purpose. Could it be used for something or something for one job, or could also be used for something else? Can we eliminate anything, or could we reverse the design pattern and think about how we use them? We did a little project previously on like a doggy dating app, and thinking about how we could change the flow of the app. Does the user need to log in as soon as they come? Is that the first experience you want that user to have? So think about how we can reverse it. So looking at our little task app now, it's functional, it's working, but we're going to go through that design process. So we can look at the functionality. At the moment, it's got text input, but what could be substituted? Perhaps we could use speech. Perhaps we could investigate that. What functionality have you learnt that could be combined? Perhaps we want to combine dictation and text input. So perhaps we want to have a little microphone icon there. When I click on it, I can speak to that application. So combining the different functionality. How can features be adapted to suit a new purpose? Perhaps we want to pull data from our iOS calendars that would populate our task list, right? So we want to pull data. That'd be a pretty cool functionality. We don't need to manually input. We'll just be editing those tasks. How can the color, shape, or form be modified? Currently, we've got no navigation, so the user wouldn't be able to navigate very easily. So perhaps we could have a tab view, perhaps we could add some sort of hamburger menu or breadcrumb menu that allows the users to explore the app a little bit more. What else could it be? I'm going to show you some other examples of this before, but what else could this application be? It's a list, it has user inputs. Perhaps we could modify this a little bit further. And then what can be eliminated? As I mentioned, we could pull the data from the task. Does that add to it? Does it increase functionality? Does it make it more complicated? Does that remove us from the task of what we were trying to do? And finally, how can we use this pattern or reverse it? Well, essentially what we've got here is like a little chatbot, right? Or our iMessages app, which allows us to stack our different messages on top of each other. So you can see how these common design patterns can be used across multiple applications. So what could this become? Well, our simple task app could become flashcards. It could be prompts for a story. It could be a number generator. It could be a dice simulator, or a project which James uses within his class is a Magic 8 Ball. A little bit of nostalgia. for the students, or some of them may not even know what a magic 8 ball is. But it also allows us to think about that interface. When James first proposed this project to me, I thought, oh, that's really cool, because SwiftUI really cool animations that we can do quite easily. So we can actually make the ball shake to reveal the new answer, the new response. So we can really start to go through this process and take our C+ project and start to build it up a little bit more to think about what is the possibility. And that's where the students' individuality, their creativity, their collaboration, and really thinking through those thinking strategies starts to be elevated. So there's a couple of questions in the chat.
Yeah, I
Some.
just saw that Steph asking like a true Malaysian. That is exactly what my students did. What's for dinner randomizer. And we did a which restaurant to go for lunch randomizer as well.
Yes, there's lots of different options. We've done fitness trackers, we've done all sorts, but essentially what we were teaching within that first project was to allow them to build up that structure and then think about what else could be applied to it.
You'll notice I keep on putting the Padlet link up for people as they join.
Yeah.
It is the same link each time, but this is really where we're going to put everything. And if Daniel gets all the permissions required, that's where the main video will go to. Simon's got a great question, if this is a good point. What year groups do you generate these sorts of apps with? I generally do it with year 9 UK curriculum, which I think is year 8 Australian and US.
Yeah, that's right. Yeah, so I do think it depends on that literacy level. Like we always say with our coding sessions run before. Depends on the literacy level. Obviously, if you're English as a second language, I don't know, I think there's a new term for that now, but English as a second language, it could become a little bit more difficult, and perhaps it gets bumped up a little bit further. But looking at where your students are.
Yeah, and we found year 9 for our students is that sweet spot. For our more able students, we've gone down to about year 8. We did try doing stuff with year 7. It was a little bit too early for the majority. They weren't quite ready to move block-based, but if you've got computing going earlier, say 5 and 6, I think there are schools I would be comfortable doing it in year 7 and 8.
Yeah. So I've seen Stephanie added a takeout option to add in bunnies.
Yeah.
I haven't been back to Australia in 4 years, so it's actually something I'm going to be looking forward to when I go back, strangely.
I hear in your town there's only one choice. There's no need to make a randomizer for it.
Yeah. That sounds right. Now, before you all start to run, keep those questions coming through if you do have them, but I do want to try and capture a little bit of feedback, but also I don't have all your emails. So if you would like a copy of the recording, perhaps you'd like to share it with a colleague or just look at some things yourself, this will capture your email so I can send you a copy of the recording. So if you could please fill out the feedback. It's very short, but allow me to capture that. I just wanted to say that before we run off, but we do have time for more questions as well.
We had a question about non-Macs. Honestly, your best alternative is probably just using Python. If that's what you're comfortable with. Visual Basic's still around, but to be honest, these days I feel Python, particularly when we're talking about using ChatGPT, the AIs are very, very good at Python because there's so much open source code.
Yeah, you can build some nice little interface.
Including using GUIs. Some keywords you would need to use are things like Takinta.
Yeah. We've also had a lot of success in building web applications using JavaScript. Again, chatbots are very good with JavaScript as well. But I think a lot of these thinking methodologies still apply. Also, we can create some pretty cool applications.
All the main slides are going to be on the Padlet. If we're missing a slide or something, then just we'll add it.
We'll just send
we
me an
have
email.
been developing this fairly last minute. Yeah.
Happy to share that.
So should all be on the Padlet.
All right,
Oh, that's great. Nice.
computer science class. That's great.
Mm. And a part of the reason that we are using SwiftUI in my school is really to give that second language, and it's a C-based language. So it's nice. We basically teach Python and Swift because we're an Apple school. If you're a Windows school, you might choose your languages a bit differently. And US schools, a lot of them teach Java, don't they?
Yeah, so one of the AP courses is Java, but the AP Computer Science Principles allows for multiple languages. So we do Swift for
Yeah.
AP.
Yeah, so it's good. Hang on, let me check. Oh, we've got another person coming in. Yeah, I mean, I think Python is a very common option. IB is moving towards Python and Java. Python works on, well, just about every platform. The only thing it doesn't work so well on, but there are apps to help with that, is the iPad itself. So yeah, Python is the number one language in the world. It works on just about anything. So that's not a bad plan for some things. But if you want to develop real apps for the real iPhone, real iPad, then you got to use Swift.
Yes. Yeah.
So in terms of monetary, as in what's the most popular language for developing apps, it's Swift, no question these days.
Yeah.
If you're looking at data science and things like that, then it tends to be Python. And in terms of most open source code, then Python, which, you know, is part of the reason that the AIs are quite good at it.
That's also why I love that Swift Playgrounds app, because the entry level is so low. I mean, you know, my 6-year-old daughter has an iPad, so she can start to play around at that entry level with coding. So I think it's a lot of schools have invested with iPads, and the ability for them to actually build an application within Swift Playgrounds and push it to the App Store, actually publish these applications to authentic audiences, is pretty huge. I think with generative AI, we can actually shorten that gap and allow students to get to that space, which is
and it's a lot less complex than learning Java, because now Swift UI, and Swift was the language. There used to be an older version of this, but Swift UI has taken a lot of the harder work out of it and made it much closer to JavaScript.
Yes. Yep.
Do you do any projects with Swift and Internet of Things? I know my son has. It is just a case of adding the APIs, because Swift will do all the user interface stuff, but then you've got to use the correct APIs depending what you are doing.
My experience with that is more depending on the board that you're going to use. Swift has very good Bluetooth libraries to help you with the connectivity. However, it just depends on what you're buying from, I don't know, the robotic sites, to ensure that you can communicate with the device. So whatever version of Bluetooth is required. But it's fairly simple in terms of the Bluetooth libraries. Remember, with your GPT tools, you can also put in the links from any documentation to help you understand it a little bit more. And the Apple documentation actually includes samples as well, which is pretty fantastic.
Yeah, Python. Yeah, they look a bit basic, don't they? I don't know what it is about Takinta, but it looks like it was back in Windows 95 kind of thing. Honestly, though, I will say, even Python, because Python in Mac uses Takinta and uses the standard stuff in Apple, I have to say, I always take Python screenshots on my Mac, because even Takinta looks better on a Mac. On Windows, it looks really old. And I know Windows has moved on, but Takinta hasn't so much. There are other GUIs for Python, before you'll give me a hard time. Some of them look much better. But they're not standard libraries. That's the catch.
Yeah, I used to do a lot of work with Pygame, and that wasn't updated for a long time. I was kind of using
It has been updated recently, and the thing about Pygame is it's really fast on the graphics. But then it's up to you to it is up to you to really design it. But yeah, it supports 3 point, yeah, it reports the 3, and we've been teaching Pygame to our Dragons coders, and they're having really fun with it because computers have got faster and faster. So what it can do is really quick.
So just before we sign off, James and I will keep talking all night. And I know everyone else has other places to go.
Yeah.
But do remember on Thursday, I'm going to have my students presenting. You'll hear a little bit less from me, a little bit more from my students about their experience with coding and building coding initiatives. So hopefully you and your students will get some inspiration from that. With slightly different format, but hopefully you'll enjoy that also. Feel free to hang around. We'll be here for a little bit longer, but that's the main gist of the content, and we look forward to seeing you all on Thursday.
Excellent. If anybody's up tomorrow morning, 6:30 a.m. Malaysian time, but that might be decent for you. I'm doing an AI session over in the US tomorrow morning, so feel free. I don't know if anybody's going through the week of AI, but it's a nice free thing, so do feel free to join in.
Ken, I just saw your question about projects with AI embedded. Do you mean creating a project which utilizes uses AI, or do you mean example assessments which students use generative AI?
Perhaps we open up his mic because there's a lot going in the chat.
Yep, we can do that. Yep.
If that's all right.
Yeah.
Let's see. Then he has a choice. I mean, there's a lot of APIs that are quite